Hello, I'll talk about the PLC lab. The PLC lab will involve a PLC, also a double acting cylinder, and we'll see how we can write down the ladder diagram so we can develop solutions to some simple um, pneumatic systems. Here, as you could see, we have a, well, we have a PLC. This is our PLC. We have a double acting cylinder. These are the things that we can measure the positions of our cylinder. We have an inductive as well as a capacitor sensor so that we can identify the parts. We have a 5-2 valve so that we can drive the cylinder. Also, we have some buttons, start and stop buttons. Okay, now, instead of that graphic, I can give you a simplified version of that photograph. So let's assume that this is our PLC. I don't know if you can see it. I can make it a little thicker. This could be our double acting cylinder, and we can measure its positions of cylinder A minus, and A plus. Let's assume that this is the area which we can measure our parts with sensors. Let's think that this is our capacitive sensor, and this could be the inductive sensor. What else? We have some buttons. Let's think that we have these buttons over here. We have 3 buttons: start, stop, and reset. And also we need to have one thing more. What is that? That's the valve. We have a solenoid activated 5-2 valve so that we can drive our cylinder. So that's about it. And we'll see how are we going to write down the ladder diagram so that we can make that system run. Okay, let me give you some example. One simple example. Let's assume that we want to have these goals for our ladder diagram. First of all, we want to start the start button, and until we press the stop button, we want the system to run. So we need to add that into some kind of a logic, but we don't want to continuously press the start button, so we want to obviously release our finger, so we want to have a latching, so we want to have that start and stop logic somehow. We want to measure plastic pieces only, so we want to implement that, and let's just add something more. So let's say detect plastic pieces, plastic parts, and we want the cylinder to push that pieces and stay in the forward position, let's say 5 seconds. And moreover, let's add something more to make it more interesting. Let's count the plastic pieces. Let's say that we want to push only 3 plastic pieces, but not more. So then we want the system to stop after pushing 3 pieces, and we want the system to not push the 4th piece. So how can we do this? All right, let me give you the answer. All right, I'll show you the system running. All right, so this is my code. I want to press the start button, but I want my stop button not pressed if I want to run. And I also want my counter in the loop. So I'm going to stop the system when my counter reached my desired set value. So I'm just defining a parameter working. So I'm just going to check that working parameter for the rest of the system. So I can put the working here. Remember, this is what we have seen in our lecture. This is called latching, so we don't have to press the start button forever. We can just release the start button, and until we press the stop button or C1 to be off, the working parameter will be continuously be 1. So we want to check the working for just, you can just now check the working parameter only, not start and stop. And we want to not have inductive, so just want to measure the plastic pieces, obviously. So we want to measure not in, we don't want to see metallic pieces, but just we want to see the capacitive sensor. So, and if we do that, we want the forward to be on, meaning that the solenoid will be on and the cylinder will have the forward motion and press it. But moreover that, we want to keep that forward motion, or let's say we want the cylinder to be in that particular A plus location some seconds. So we want to add a timer. Let's call it timer 1, and let's say that once it hits A plus, the timer starts, and when until when we have the timer 1, so it's going to wait let's say 5 seconds. After the 5 seconds, it is going to run reverse. So it means that it is going to push the part and wait 5 seconds there, and when the timer is reached the 5 seconds, the T1 will be 1, and the system will be put into reverse position and the cylinder will reverse. But moreover that, we need to add a counter. Remember, we required to count some pieces. So this is A minus, and let's see, this is our counter. Let's call it C1. We want to count down, so we can have the number 4. We may as well reset the counter whenever we need. So I mean, pretty much this is the ladder diagram. So that is going to so what happens is you will press the start button and the system will be in the working mode. So working will be 1. Once is in the working is 1 when you don't have any information from inductive, but you have a capacitive information, or meaning that you have a plastic piece, then forward will be activated. The cylinder will push it, and once it hits the A plus, meaning that it's in the forward position, it is going to wait 5 seconds. After that, it is going to be put in the reverse position, and then once it came into the A minus, it is going to decrease the counter from 4 to down, and let's see whether it's going to work.